Okay, I've been asked to do kind of a little rundown on all of the tests that we use, and maybe what we look for to decide which test we use. I know some people are confused on the test, and maybe also I'll combine this with this sheet that has all the conditions on it that I sent you a while back. Hopefully you still have that. So I'm just going to roll straight through the calculator. First, the z-test. So remember, the z-test and the t-test are kind of together. The z-test and t-test are both for means. So anytime you hear the word average or mean, those are the tests you're going to use, as well as the z-interval and the t-interval. So the mean is the key, right? And the difference between z and t is very simple and very straightforward. If we know the population standard deviation, you use z. If you don't know the population standard deviation, you use t. That's what we do in our statistics. So some of you I know have been looking those up in other books or on the internet, and you're finding out different things, and there are different things at different levels. So normally in the real world, a t-test is basically less than 30, and a z-test is more than 30. We don't really use those distinctions right here. We kind of still do, because you need that 30 to be normally distributed, hence the t-distributions if it's less than 30. But we use the condition of knowing the, if you look here, right? Sorry. Next sheet for the z-test, we know the standard deviation of the population, right? Same with the z-interval, same with the t-test. The t-test is unknown, and the interval is unknown. The two samples, both for the test and the interval, so way up here, we have a two-sample z-test and a two-sample z-test, z and t, sorry, and we also have a two-sample z-interval and a two-sample t-interval, same deal. We're looking for the difference of means here, right? If they're independent. So if we go here, two-sample z-test, notice two independent simple random samples for the z or the t, two independent simple random samples for the interval or the test, doesn't matter which one you're doing. Same main difference here. When do you use, these are always mean, right? Average, 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 that's what you're looking for. Population standard deviation unknown, population standard deviation known. That's the only difference between the z-test and the t-test. And that covers, what do we got? 8 of those, right? So we got z and t and two samples z and t, and then we got those corresponding z-interval, t-interval, and two sample t and z. They all have their conditions. I'm not going to go through all the conditions because you can look it up, but normal sample size or normal population, sample size big enough, those sorts of things. So we have the proportion test and interval. So 1 or 2, right? Actually, you know what? I'm going to jump to if they're not independent, because in this two-sample independent, if we go somewhere, let me find it, just down here at the bottom, that if your samples are not independent, we've had a couple of those in class work, and a couple of those on the FRQs also, then we just do a t-test, single sample test on the actual differences. So you have to decide if they're independent or not. That's the trick. Often you'll see a chart that connects the two numbers, right? That's the main reason where you might see something that's not independent. So for instance, you might have person A with 2 different numbers. Pretty clear kind of set that they're not independent. If they're not independent, then we just look at the differences. We have like a third column here, the differences. So you find these differences, you find that mean, you find that standard deviation, and then you just do a 1 sample interval or a 1 sample test in that case. Proportion. People get confused with the proportion because there's no t proportion. It just doesn't work that way. So all you have is the 1 proportion z-test. That's testing. That's testing a proportion, 1 proportion or 2 proportion z-test, and same things. You go down here with the intervals, right? 1 proportion z-interval, 2 proportion z-interval. Those are proportions. Anytime you hear percents, you're going to be doing one of these tests. We might believe the proportion of something is 0.4, and we're going to test that. We might believe the difference between 2 is number. We're always testing that the difference between the 2 is 0. So the key thing that you're looking for there is proportion. Proportion, pretty straightforward. on that. And then here are the tests on those. We have a 1 proportion Z test and interval. The conditions are always the same. We might change between p-hats and p-naughts and things like that. Just again, down here, notice for the proportion problems, there's no condition about normal population. Just a big enough sample size. There's also the reason there's no Z or there's no T. Or I'm sorry, there is no T. There is just a Z. Because that's all we know. So it's always Z on that one, which I know can be a little confusing. And then those are the main ones, I think, that hopefully that helped a little bit. We got, we did all these test intervals, and then we got the chi-squared test, right? The chi-squared test, the chi-squared goodness of fit test. The chi-squared test tests both independence and homogeneity. You're going to do the exact same math. Your wording will be different. Grab that one here. The wording will be different, and usually it's really easy to tell the difference if they just say, is there a relationship? That's going to be a test of independence. If they say, are the percents of A, B, and C the same for populations 1, 2, and 3, that's homogeneity wording. If they don't give you the wording, if they just say find the proper test, then it comes down to this little statement here. The main difference between independence and homogeneity is how you take the samples. Independence is one population, so you have one simple random sample in that particular case, and they would ask 2 questions. What's your gender? Did you pass the test? That sort of thing. Homogeneity has multiple populations, so it would be like stratified samples. So you would take your males and females and separate them and do a simple random sample for both of them. You've now turned it into homogeneity. Just ask them, did you pass the test? So it's just how you took that original sample. If it's one simple random sample, homogeneity or independence, and if it's multiple simple random samples, then it's homogeneity. Normally, you don't have to worry about that. Normally, you just have to know the wording. The wording is the key thing. And then the last one on here are the t-tests and t-intervals. Pretty straightforward for these. There's not any confusion. I think when you use these, you just use these to find slope, right? Interval first, slope, that sort of thing. This sheet is super important. 4 pages. I'm going to send it to you again probably as we get a little closer to the test. I think I already have once for sure, maybe twice. I can't remember. Print it out. You're going to want to have this with you during the AP test and my final exam. It's all open book. Quick reference on the sheet. So hopefully that helped a little bit. Let me know if there's any questions.